Hi guys, we're going to continue with chapter 10. This is actually the last section in chapter 10. It's a short chapter. So we'll have a review and an assessment after this section here. And this section is called Inverse of a Function. So here we go. So when a relation contains a comma b, that point, the inverse relation contains b comma a. So when we're talking about an inverse, all we're doing is we're reversing our points. So for example, if we have the point 2, we have the point 2 comma 3. I don't know why my pen's not working. There we go. 2 comma 3. Then the inverse, all we do is we just switch our x and y, okay? So the key thing here, when you're talking about an inverse, is that you're just switching your x and your y, okay? That's the big thing when we're talking about what an inverse is. So let's look at some examples. Find the inverse of each relation. So if we look right here, and I'll highlight our regular function, right here are the points in our function. Then the points in the inverse, all we're doing is we're just switching the x and the y values, okay? We're just switching what we have in our x and our y. So if our first point is negative 4 comma 7, then my inverse is going to have the point 7 comma negative 4. So it's just a reverse of the x and y values, okay? That's all we're talking about when we're talking about what the inverse is. Just go ahead and switch the x and y values. And you can see that whether you see it in a set of points or if you see it in a table where we're talking about the inputs and the outputs. So for example, if I have an input of negative 1 comma 5 in my function in the inverse, it'll be 5 comma negative 1. We're just switching the x and y values. If I have 0, 10, 0 my input, 10 my output in the inverse, then 10 is my input and 0 is my output. So you're just switching the x and y values or the inputs and the outputs when you're talking about dealing with the inverse. So let's just look at a quick example here. Find the inverse of the relation. All we would be doing is switching my x and my y values. So what would the points be? They would be negative 4 comma negative 3, and then 0 comma negative 2, 4 comma negative 1, 8 comma 0, 12 comma 1, 16 comma 2, and 20 comma 3. So that would be my inverse, okay? The inverse just switches those around. If I see it in terms of a table, again, my inverse would just switch my inputs and my outputs. So my inputs and my outputs would just switch around. So instead of having negative 2, 4, I would have 4, negative 2. Instead of having negative 1, 1, I would have 1, negative 1. And you could fill out the rest of the table on your own. This one would actually be the same. 0, 0, 1, 1 would be the same. And then I would have 4, 2. So you're just switching the inputs and the outputs. Let's look at our second example where we have f of x equals 2x plus 1. And it says solve y equals f of x for x, and then find the input when the output is 3 or negative 3. So the first thing that we have to do is we have to solve for x. So we really have the function y equals 2x plus 1. And what we're going to do is we're going to solve for x. So I'm going to subtract 1 on both sides. I've got y minus 1 equals 2x. And then I'm going to divide by 2. And I could just leave it like this. Y minus 1 over 2 is equal to x. Now it's saying find the input when the output is negative 3. So what we're saying is, okay, our y value, now, on highlighter, our y value is negative 3, and we're going to substitute that in, and we'll get what x is equal to. So negative 3 minus 1 over 2 is equal to x. because remember, input is x and output is y. So negative 3 minus 1 is negative 4. So I get negative 4 over 2 is equal to x. So negative 2 is equal to x. And there's my solution. So when you see a problem like this, your first step would be to solve for x. And then after you solve for x, you're going to substitute in that output that they're giving you, and you'll get what that actual x value is. I don't think we need to go through these examples here. Just one note, if you want to, remember you're always solving for x. Now, finding the inverse of a function algebraically, we have to set y equal to f of x. So we're going to just, if they give it to us in f of x, we're going to make it y equals. We're going to switch x and y in the equation, and then we're going to solve the equation for y. So let's find the inverse of this function. So we have y equals 4x minus 9. So we've now done step 1 where we've set y equal to f of x. And now we're going to switch x and y in the equation. So x equals 4y minus 9. And now we're going to solve for y. So we're going to add 9 to both sides. We're going to get x plus 9 equals 4y. And then we're going to divide by 4. So you can write it as two ways. You can get y equals x plus 9 all over 4. Or a little bit better way would be y equals x over 4 is the same thing as 1/4 x plus 9/4. Okay? And that would be our solution there. I'm going to keep this. I just want to go through one other thing. Okay, and you can check your works. You can check your work rather because the graph of g appears to be a reflection over the line y equals x. So that's one other key component here. When you're finding an inverse, they're actually a reflection over the line y equals x. Let's look at a couple more of these. So let's look at one like number 8. So we're going to start with y equals 1/4 x minus 1. Then we're going to switch our x and y. So we're going to get x equals 1/4 y minus 1. We'll add 1 to both sides. So now we've got x plus 1 equals 1/4 y. Now to get rid of the 1/4, we're going to have to multiply by 4. And I have to multiply by everything by 4 here. So I'm going to end up getting 4x plus 4 is equal to y. And there's my inverse. And then you can graph both of these using Desmos. I'm going to show you how to do that right now. So we've got y equals 1/4 x minus 1. So let's graph that. Y equals 1/4 x minus 1. And then we've got y equals 4x plus 4. 4x plus 4. Okay, now I want to show you that the line y equals x is a reflection. Okay, if we reflect this blue line to this line, you'll notice that it's a reflection over the line y equals x, which is what all inverses are. And if we look here, let's look at some points. 0, 4, so I should have the point 4, 0, which I do. I have a point here at, well, I don't want that exact point. Let's get this one. -1, 0, so I should have a point at 0, -1, which I do. Okay, so you can see that you have all of these points that are inverses of each other, which is what should be happening if I've done it correctly, which I did. Okay, find the inverse of f of x equals x squared. So now we're going to go through the same steps, but it's a little bit more challenging. Y equals x squared. Now we have to switch our x and y. So x equals y squared. Well, how are you going to get y by itself? Take the square root of both sides. So what's the inverse here? The inverse is the square root of x. Let's check. Okay, and I could see I've got f of x equal to x squared, and then the inverse g of x is equal to the square root of x. Okay, and there are two functions. We have this thing called the horizontal line test. The horizontal line test says that the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So remember, we had the vertical line test, which will tell you is something a function. Now we have what's called the horizontal line test to determine if the inverse is a function. So here's the graph, the function f of x equals x, the square root of x plus 2. Determine whether the inverse is a function, and then find the inverse. So let's take a look at the graph. Square root of x plus 2. Go back to Desmos, get rid of all this. Y equals, and let me get square root in here. Square root of x plus 2. Now I'm doing a horizontal line test. So remember, we had the vertical line test. Now we have a horizontal line test. I can see that it's not going to cross in any more than one spot if I draw in some horizontal lines in here. So I know that the inverse is a function. Okay, so the inverse is definitely a function here. Why is it a function? Because it passes the horizontal line test. So inverse is a function. And we know that because of the horizontal line test. And now let's find the inverse. So I'm going to have y equals the square root of x plus 2. I've got to switch mine around. So I'm going to have x equals the square root of y plus 2. Now I've got to square both sides. So I'm going to have x squared equals y plus 2, because this will cancel out. Subtract the 2. I'm going to get x squared minus 2 is equal to y. And there's my inverse. Okay? And if I go and I graph that, if we go back to Desmos and I graph y equals x squared minus 2, it's actually an inverse of the function that we see there. All right, I'm not going to go through these, try these. You can do those on your own, following the same examples that we did. All right, so key things in this topic: know that when we're talking about an inverse relation, all we're doing is we're switching the x and y values. When you have to find the inverse, go through these steps right here. First, change it from f of x equals to y equals, then switch x and y in the equation, and then solve the equation for y, as we did on several of the examples here. Okay? And final thing, make sure you know the horizontal line test. The horizontal line test will tell you whether or not the inverse of a function is also a function. So make sure that you're aware of that. This is the final section. Keep up the good work, guys, and I'll see you next time. See ya.